Good afternoon, everyone. I hope I am audible.
Ma'am,
Okay. Okay. So yesterday you have learned about this all the different kinds of demands and all the different kinds of drafts. Okay. So today we will be learning about the population forecasting method, and also before knowing the population forecasting method, you have to know what is one term is there name is design period. Okay, so basically what is a design period actually, like whenever you are going to suppose design a water supply scheme, each component of this water supply scheme, they are very costly. Each structures, they are very costly. You cannot, after after you have constructed a water supply scheme, whether it is a dam or it is any type of reservoirs, after you have constructed and suppose if there is any kind of, you have to change something, so that is not possible for very, very easily. It is not convenient also, and it will take, so much of money. Okay, so it is not economic. So like whenever you are going to design a water supply scheme, since it is such a huge a project, you cannot change each and every component of this water supply schemes, and yeah, very easily. So what we do actually is that whenever you are going to design a water supplies scheme, or you are whether it is a distributing, it is a pipe, or it is like which are laid, underground. So it is not possible to replace, and it is without whenever you are going to replace it, so much of disturbance is happening. So what we do is that whenever we are going to design a water supply scheme, so what we do, we take the we take into account the number of population for like 30 years. For next 30 years we are going to design the water supply scheme. We are not going to design the water supply scheme only for the present year. It is not like that. We are going to design the water supply scheme, whether it is a dam, or it is a distributing pipe, or whatever it is. So any component of this water supply scheme, whenever we are going to design, we are going to design it for a very larger period of time. Supposedly it is taken as suppose 30 years, or 15, 30, 20 years, like this we are going to design. Okay, now we have to take into account, like for next 30 years or for next 15 years, what is the number of population that it is possible to that it is there. Okay, like for the next 30 years, how much of population will be there. So that is like for whatever number of years, for whatever number of years you are going to design, so that is your known as your design period. Okay, for the next number of years, for the future period which you are going to design the various components of the water supply scheme, so that is known as your design period. Okay, and this design period, it should not be very long, or it should not be very short, or for a short duration. Then again, now we, after knowing the design period, we have to know what is a population forecasting. What is population forecasting? So as I now already, it's been I explained with this one only, that this population forecasting, that you are like it is done to know the population for the future years. Okay, for the future years, what will be the population for next 30 years, or what is the population for next 20 years, so that after knowing the number of populations for next 20 years or 30 years, it is easy for you, or it is convenient for you to design a water supply scheme. Okay, and this population forecasting method, it is actually not like, it is not that appropriate, not appropriate, I will say, it is not that exact method. Means I mean to say that whatever values you are getting, it is not like that you have, it is exact value will be your future number of populations. It is not like that. It is a, it is a this whole this population forecasting method, it is based on the laws of probability. Okay, like it is a approximate values you have to take. It is not like that the exact number of population, whatever it is coming, you are going to design for that only. It's not like that. It is a like a probability type of thing, and you have to take the approximate population based on that number. So it is like that. And now for the population forecasting method, we have, under that we have many kinds of, population forecasting method, but all we are not going to discuss in our subject. We are going to discuss about the three main types of population forecasting method. So this number one is your arithmetic increase method. So basically this arithmetic increase method of population forecasting, basically it is dealing in a city, or for a population, you can say, for a already developed city, you can say, where the population, it is not increasing with the respect of time. This those kind of cities, or those kind of towns where the population is already been, or where the city is already been developed, where already the industries has already been, it has been constructed, or already the whole the city, it is developed, and there is no increase in any population, or no increase in any number of industries. Basically it is a kind of this method is used in this is actually arithmetic increase method is obsolete nowadays, and these are not used nowadays, because nowadays obviously population is increasing. So this method is generally used for old cities and towns where there is no kind of any kind of increase, population increase, or where there is no increase in industrialization. So in these those kind of cities, this arithmetic increase method is used. Basically you have to know the formula for arithmetic increase method. So here you can see, this is the formula for your arithmetic increase method. This equation you can see, Pn is equal to P naught plus N into X bar. So each and every terms here, they are having a certain meaning. So here basically Pn, what it means is that whatever, for whatever number of decades you are going to find out the population, so that is your Pn. Suppose you are going to find out the population, suppose in the question it is given to you to find out the population after 2 decades or after 3 decades. So or population you find out in 1980. So whatever population you are going to find out, so that is your Pn. And in this formula here, we are not talking about the number of years. We will not be dealing with number of years. We will be dealing with the number of decades. Okay, we will be dealing with the number of decades. So I hope everyone knows what a decade is. So 1 decade is equal to your 10 years. So we are talking here about only about decades and not about years. Okay, so here Pn is the number of population after a certain amount of after a certain number of decade. So and p naught here is the whatever population, the last population of a certain decade is given to you, so that will be your population, that is your population p naught. So, in simple words you can say it is the last known population. Suppose your population for the year 2000, 2001, and 2002 is given to you. So 2002 will be the last population that you know. Okay, that is given to you. So that is your P naught. It will be clear to you while we will be solving one numerical related to this method. Okay, so n, as I said, it is the number of decades. It is not number of years. N is the number of decades. Then x bar is the, you know, the average increase in population. What is the increase in population in average? So that is your x bar. We have certain formula for finding the x bar also. Okay, so now to make the formula more clear to you, we have to go through one numerical for each of this, like forecast, population forecasting method. So the numerical, very simple numerical we are going to discuss. The question, it is this one, okay? The question is like you have to find out, um, okay, the population of 5 decades from 1930 to 1970 are given below in table 2.9. Find out the population after 1, 2, and 3 decades beyond the last known decade by using arithmetic increase method. So here the population of 5 decades, that is from 1930 to 1970, is given to you. Okay, 1930 to 1970, the populations are given to you, and you have to find out the population after 1 decade, 2 decade, and 3 decade. As I say that 1 decade is equal to 10 years. So after that means 1970 is the last known population here. So you have to find out 1980, 1990, and 2000. I hope this is clear to you. Okay, so since it is, you have to find out the population after 1, 2, and 3 decades, that is from the last known population, you have to find out the after 10 years gap. That means that is your 1980 you have to find out, 1990 you have to find out, and 2000 you have to find out. Okay, so this table is given to you. Now you have to make another table for your arithmetic increase method. Okay, so you have to remember this, all this table, you have to remember how to make the table, and also you have to remember the formula for arithmetic increase method. Okay, so the table you have to remember is like this, that first column it will be your year, whatever year is given to you, you have to write this year. Then second column will be of your population, and third column is your x, that is we have in the formula we have x bar. So we need the increase in population. What is the increase in population for the certain decade? So here also we have one, the method how to find out this x we have. So these three columns you have to remember. For all these forecasting methods we have similar kinds of tables. If you can remember the arithmetic increase method table, so you can easily go for the next method. You can easily solve, because that is also we have a similar table. Okay, so first column will be of year, population also it is given to you, only you need to find out the increase in population, that is your x. Okay, so write down the this column, first column, it's 1930, 1940, then up to 1970, as it is given in the question, you have to write it down. Okay, so 1930, 1940, 50, 60, 70. So in 1930, what population we have? So in 1930, what population we have? We have 25,000. Yes. So here we have written 25,000. And again, in 1940, what population we have? We have 28,000. So we have written here 28,000. So similarly for 1950, 1960, 1970, whatever populations you are having, so you will write it down. Similarly, 34,000, 42,000, 47,000, likewise. Okay. So now our main aim now it is to find out the x. How will you find out the x? So if I name this population as suppose P1, okay, and this as suppose we are taking as P2, okay, then number 3 as we are taking as P3, okay, then P4 and P5 similarly we are taking like this. So what will you do? You have to subtract the, with the big, the increasing population with the smallest population, like this. Okay, for suppose you are finding for 1930 to 1940 you are finding out, so you have to subtract P2 minus P1. Okay, you have to subtract P2 minus P1, that is 28,000, okay, minus 25,000. Okay, then you are getting 3,000. Clear? Then for the next kind of decade, that is for between 1940 to 1950, you are finding out the increase in population. Then you have to subtract 34,000 and 28,000. So you are getting 6,000 here. Then again, you have to find out between 1950 to 1960, it is your 42,000 minus 34,000, that is your 8,000. Okay, then similarly for between 1960 to 1970, again similarly, you have to subtract 47,000 minus your 42,000. So you are getting 5,000. I hope up to here I am clear to you. Okay, so we have found out the X now. Okay, we have found out the X. So 28,000 minus 25,000, here 3,000, then 34 minus 28, 6,000, then 42 minus 34, we are getting 8,000, then 47 minus 42, we are getting 5,000. Now, since you need the average increase in the formula, that is your X bar, we have a formula of the arithmetic increase method. Okay, this one is the formula. Okay, so this one is the formula. Pn is equal to P naught plus n into X bar. Just now we got, okay? So now here we need the X bar, okay? So you need the average increase of population. So what will you do? You will just divide with the mean. Okay, divide it with the mean. Here it is 4, since here your 4 values are here, 1, 2, 3, 4. So you will just add it up. Okay, so you will take the summation of the increase in population, that is it will come out to be like 5,000 plus 8,000 plus 6,000 plus 3,000, you will get 22,000. Okay, you will get 22,000. Then you have to divide it by its mean, that is here 4 values are there, so you are dividing it by 4. If there are 5 values, so you will be dividing it by 5, or whether it will be here, if it is 6 values, then you will be dividing it by 6. Okay, similarly it will be different for different type of numericals. Okay, so after dividing, you are getting the average increase that, for the per decade, you are getting the average increase as 5,500 after dividing this 22,000 divided by 4. Okay, so now you have got the X bar. Okay, now everything you have, the formula is now with you. Okay, the formula is with you. So now you can easily find out the population for the first decade, second decade and third decade after the last known population. Okay, last known population was given to you in the question was 1970. So after 1970, the what is the next decade, that is your 1980. Okay, then after 2 decades it will be 1990. Okay, and then after next it will be 2000. Okay, it will be 2000. So you have to find out these three. Okay, these three you have to find out. Now this one is the process. Just you have to put the all the values for 19p 1980. You are finding out for the population for the year 1980. You have to what is the formula? P naught is the last known population. What is the last known population mentioned in the question? It is your 47,000. Yes, this is the last population that you can see. It is given to you. It is your 47,000. So P naught will be 47,000 for all the 3 decades. Okay, so this is your 47,000 plus it is 1. N is 1. Why? Because you are finding out after 1970. Okay, after 1970 you are finding the next decade, that is your 1980 you are finding. So what is the difference of decade between these two? It is 1. Okay, what is the difference between these two decades? It is 1 decade, that is 10 years. Since here we are dealing with number of decades, so it will be 1. Okay, so here this number of decades small n is your 1 multiplied by what is the X bar we got? X bar we got is your 5,500. Okay, so after doing this whole okay, after getting this all these things, so you just do the this one, and you will get the answer. You will get the answer. Okay. So similarly, you find out the population after 2 decades and after 3 decades. Okay. You find out the population after 2 decades and after 3 decades. So you will get the answer for your 1980, 1990 and 2000. Okay, for all the 3 decades, you will get your answer. So this is a simple numerical. I hope everybody is clear with the numerical.
Yes, ma'am. Yes.
Yes, okay. So what you do, this thing already you have with you. I have already shared. So today after the class, you just like this. If you will see, then obviously you will forget. It is known only. Okay. So what you do, you just do it in your copy. Don't just see in the class and just keep it in your in your brain. Not like that. Just you have to practice it in your copy. Okay, do it in your copy. Then you see if you can understand or not. Okay. So today I won't be doing the next method because it will again confuse you with the other three methods. So up to here today I will be doing. You nicely you do it in your copy, and tomorrow next class I will be doing the next two methods. Okay, you just for today you remember the table, you remember the formula. Okay, after that next class we will do the other two methods. Okay. So let me I will be sharing the Google Form link in your class group. Okay, I will just now I will be giving the link. Okay, then everyone, thank you.
Thank you, ma'am.
Thank you. You may
Thank you,
leave
ma'am.
the meeting.